Your engine oil looks clean, but your filter could be quietly choking your engine to death. In heavy-duty trucks, oil filters aren't just about maintenance items, they're silent protectors of the entire engine. And when they start to fail, they rarely scream, they whisper. Subtle pressure drops, slight flow disruptions, and contamination too fine to the naked eye. By the time you notice something's wrong, it's often already caused serious internal damage. That's why understanding how oil filters really work and how they fail is critical to keeping your fleet on the road. Now, let's dive into what makes oil filters so different, how they're built, and why choosing the right one is more important than ever. When it comes to oil filters, not all are created equal. Their differences lie in not just size and shape, but how they control the contaminants and manage oil flow. The most common type is the surface type filter, which are typically used in trucks. These filters trap contaminants on the surface of the media as oil passes through. For more demanding applications, depth type filters are used. These contain denser material that allows the oil to travel through a more complex path, trapping contaminants deeper within and holding significantly more debris. Oil filters are also categorized by how the oil flows through them. A full flow filter routes oil through the filtering media, ensuring complete filtration. A bypass filter processes only a portion of the oil, which helps maintain proper flow rates in the system, where full flow filtration can restrict the oil movement. Another approach is the duplex system, which features two filters set up in parallel. Most canister filter types direct oil flow from the outside in, meaning the oil moves from the outer surface of the filter media towards the center. However, some filters reverse this direction, pushing oil from the core outwards through a specifically designed pleated structure. This design can enhance flow distribution and reduce the overall size of the filter elements. Each type of oil filter is designed with specific performance goals in mind, all aiming to protect the system by keeping the oil as clean as possible. An oil filter may look simple from the outside, but on the inside it's made up of several key components, each playing an essential role in maintaining proper oil filtration and system integrity. The base plate forms the structural foundation on the interfacing end of the filter. It supports the filter media and helps prevent leaks and ruptures under high pressure differentials. In many designs, it also contains the threaded connection to attach the filter to the filter head securely. Surrounding the filter is the filter housing. Often referred to as the bowl, this outer shell directs oil flow through the filter element, which also protects the internal components. At the heart of the filter is the center tube, or the inner core. This component supports the filter media from within, keeping it from collapsing under pressure. It also serves as the central path for filtered oil to exit the filter and return to your system. The filter media is the main element responsible for removing contaminants. Often pleated for increased surface area, it can be made from a porous cellulose or synthetic material. This structure captures dirt, metal particles, and other impurities during normal oil flow operations. On either end of the media are the end caps, which provide additional structural support. Like the base plate, the end caps help prevent bypassing, ruptures, and leaks, especially under increased differential pressures. Some filters are equipped with a drain port, which allows oil to be drained from the system housing before the filter is removed. This makes the servicing cleaner and safer, and it can also be used to take oil samples or reduce waste before disposal. To ensure a proper seal during installation, the base plate gasket is used. This pre-lubricated O-ring or sealing ring sits between the base plate and the filter head to prevent oil leakage under pressure. Finally, there's the dust seal, which protects the filter's interior from external contaminants. It prevents debris, dust, dirt from entering the filter housing before or during installation. At the heart of every oil filter is the media, a porous component designed to remove and retain contaminants as oil flows through. The effectiveness of the filter comes down to how this media captures particles, and that involves several filtration mechanisms working together. One of the most straightforward is direct interception and depth entrapment, where particles are simply too large to pass through the media's pores and they get blocked. Absorption adds another layer where contaminants cling to the media's surface due to electrostatic or molecular attraction. Next is inertial impaction, which occurs when the flow of oil causes heavier particles to slam into the media and stick, often aided by absorption. Then there's the Brownian movement, which affects the ultrafine particles under 1 micron. These tiny contaminants move erratically, allowing them to come into contact with the media and be captured, even without being directly in the flow path. Though this is more effective in low viscosity fluids, it still contributes to fine filtration. Lastly, gravity allows heavier contaminants to settle away from the fluid path, especially when oil flow is slow. The media itself can trap contaminants in one of 2 ways. Surface retention holds the particles on the outer layer of the filter, while depth retention traps both on the surface and deep within the media's internal passages. Depth-type filters tend to be more efficient at capturing smaller particles due to the increased number of contact points. They also benefit from the absorption of the Brownian motion, but they often create more resistance to oil flow, leading to higher pressure differentials across the media. While oil filters are designed to protect engines and systems from harmful contaminants, they themselves can become a source of failure if not properly selected, maintained, or installed. Understanding common filter failure modes is key to preventing unfiltered oil from damaging critical components. One common failure mode is channeling. Under high differential pressure, the passage within the filter media can widen, creating unintended pathways for oil to bypass the filtration process. Not only does this allow contaminants to pass through, but it can also release particles that were previously captured along the compromised route. Another issue is fatigue cracking, which can develop under cyclic flow conditions. Repeated pressure fluctuations can cause small cracks to form in the media, providing a direct route for unfiltered oil to escape into the system. Media migration is another serious concern. Over time, the fibers that make up the media can break down and enter the oil stream as new contaminants. This can be the result of mechanical vibrations from improper installation, poor housing fitment, or failure caused by exposure to incompatible oils and extreme pressures. Finally, filters can experience plugging, which happens when a media becomes completely clogged with contaminants. While this may seem expected at the end of a filter's life, it can occur prematurely if the oil is contaminated with water, coolant, sludge, or other oxidative byproducts. When plugging occurs, oil filters can become severely restricted, or in some cases, bypass valves may open and allow unfiltered oil to circulate, defeating the purpose of the filter entirely. Each of these modes of failures highlight the importance of choosing the right filter for the application and monitoring both the conditions of the oil and the performance of the filtration system. Oil filters may not be glamorous, but they are vital. They quietly protect our engines, machines, and systems from catastrophic damage, day in and day out. Understanding how they work, what they're made of, and how they can fail is key to getting the most out of your equipment. So next time you're choosing an oil filter, don't just go by price or size. Look under the hood and consider the science, because clean oil isn't just about running smoother, it's about running longer.